What is the opinion of the crowd here? Should we get started? Okay, so welcome to our first hybrid event at the Connectory after the lockdown. As you can see, I don't have a mask, but I wear it all the time. So I'm very happy to say that we have been working very hard to enable events like this that will allow us to do collaboration in person. Very specific thanks to the guys from IBM that came from Michigan, came from Chicago, but that are helping us carry on with the mission of the Connectory. What we want to do is connect the ecosystems and make sure that we have the tools and putting in front of everyone the knowledge of what we can do and what we can enable into the future of IoT. So we are the setup is amazing. Thanks, Kevin, and thanks, Michelle. Thanks, Sarah. Thanks, Grace. Thanks everyone for making this happen, and everyone else online. Thanks for joining as well. I know it's hard sometimes to do these things remotely. We're trying to make the best show possible for you so that you can understand what we're doing here, and there will be chances for questions. And Morgan will take care of getting us through the different areas of the presentation. So. As a reminder for everyone, we have 6 connectors around the world. So now more than ever, we can connect truly all the connectors that we have out there. So take the chance to connect with us and take advantage of everything that we have to offer. Please note that this event is being recorded, so everything you say and show will be available. And if you want a copy of the recording, let us know. We'll be very happy to provide. So that being said, I would like to give a warm welcome to Tony, Morgan, and please do enjoy, guys. Welcome.
Thank you, Furman. As Furman said, my name is Tony Nelson. I'm from IBM. My role is as the solution specialist for Maximo and the IoT connected solutions for industrial markets in North America. So I'd like to welcome you to our presentation that we are calling the Driving Operational Experience from Visual Inspection. And we're going to be walking you through a few demos today as well. So quick introduction. We're going to drive right through some introductions today. I'll introduce you to Morgan as well as a couple of remote people that we have on the call from our team. And then we're going to go through a high-level overview of what the application is and what it does, and at a very high level how it works. I'm going to roll into a first demo with Morgan, and then we're going to talk about our processes, how we get you engaged, what the next steps are, and how these production pilots work. And then we're going to go into a second demo, which I will lead, using some actual cars built by some of my automotive engineers, and we'll get moving on with that. So as I said, my name is Tony Nelson. I'm an account representative or solution specialist for the Watson IoT. We have Morgan Renke. He's also here physically in Chicago. He's a client technical professional. He's a lot smarter than I am. And we also have 2 other smart people on the phone. John Ward, who is he's located in South Carolina right now, but I'm happy to have him on the call because he's knows more about VI than I will probably ever know. And then we've got Dave Doherty, who is also incredibly smart and technical and has acted as sort of a mentor for both Morgan and myself as we've journeyed along this IoT path. So I'll just pass it off to Morgan right now.
Thank you, Tony, for the introduction. All right, everyone, we will go ahead and hop into it. So, going to be pretty excited today. This product is really cool. I've loved playing with it. It just moved over to the Maximo portfolio. So if you haven't seen it yet, you're in for a treat today, as well as it's going to also be within our Maximo portfolio. So you'll see a lot more of it. So I know I've showed this slide a lot, especially if you've come to Tech Talks before, but we're going to go through it again because I think it's really important. And I really think about it as a maintenance maturity chart or operational maturity chart. So in the bottom left, you're really talking about managing your assets of your facility and your operations. That's, you have all the information on your assets, you're conducting maintenance, you're doing preventative maintenance when you should, and then you have job plans and tasks. So when you want to complete those work orders, you have all the steps and you're doing consistent and standardized work. Now, what that is preventing you from in the maintenance world is unplanned downtime. So downtime that you're not expecting. So really the next rung on the maturity curve is this monitor aspect. And that's looking at real-time analytics of your assets, as well as what we're gonna be looking at today with AI vision and visual inspection, and doing that in conjunction with your direct goods. So say that you're getting a high vibration off of one of your assets, and then you're also getting some dings and scratches or cosmetic issues within your direct goods. That's the information that you want to know. Not saying that those are connected and that is the reason, but giving you more insights into how you're operating so you can improve your operations in the future. Now looking at the health step, you're taking all the information you have from manage and from monitor and how it's supposed to be performing and giving your assets a health score. So when you work in a factory like I used to, and you have 1 million square feet, a lot of different assets, a lot of things to maintain, you have a hierarchy of, what's showing the lowest health score, and then what is our highest priority. So we can start to do our maintenance on a basis of, what's looking like it's having issues, what's the highest priority, so that we stay up and running and we don't have as much downtime. And then really the gold standard, prediction and predicting when your assets are going to fail, why they're going to fail, and then planning maintenance based upon that. So I did want to touch on that again. We're going to be again in the monitor step with the AI vision and visual inspection and being able to detect anomalies not only on our assets, but also on our direct goods. So there's really two flavors of AI visual inspection, and I'm going to go into that, but I want to start with how do we get the data that we need to start training these models to start inspecting our direct goods? So looking at the quality assurance and how we're operating. There's two different ways. You can do it from local storage if you already have photos, which is on the bottom left, and then you also can do it through our iOS devices. So where you're wanting to do these inspections, you can set up these iOS devices or your cameras and start taking photos, collect those photos that then can be part of the data ingestion. I then like to look at really the visual inspection in the middle, which is what I kind of call like our web browser to kind of make it more clarity. And what you do there is once you've collected those photos, you're telling the models what's important. So you're labeling the objects that you want it to either be detecting the presence of for good or for bad parts. And then based upon that, we're able to do some augmentation, do some different manipulation of that data to then train those models and then test them. And we can do inferencing from the training server as well. Now, once we've tested our models, we're happy with them, we're able to export those models via our API, and that can be to a local inferencing server, which you're seeing up top with cameras. So these would be cameras that are pulling the information to a local inferencing server that then will then go ahead and do the inspections. But if you want to be a little less hands-on, don't have to connect to a PLC, you can do the visual inspection mobile app, which is run on iOS devices that can do the inferencing local. So really two flavors right there. And we'll kind of go into both of those as we continually go through the demo. So I like this slide. It's a lot to look at. There's a lot to read, but it's a few different use cases that we have. And a lot of our experience so far has been within the automotive. And it really goes across industry. So you're looking at defects such as, and you can see in the photo in the top left, right here, electrical connections or connectors at all. So making sure that the electrical connections on a car are connected, as well as gas lines are connected is pretty important. And you're doing it at where the installation is occurring. So you're catching it there instead of down the line. Another one is missing parts. So as you can see with the wheel, we've seen in the past where there's issues with getting the right lug nut on, or even a lug nut at all, and it misses it. So catching that there before catching it when it gets on the parking lot at the dealership. And then incorrect part installation, I kind of went into that with the wheel. Part damage, looking at scratches, dings, flaws. That's something that if you're doing it manually and humans are doing these manual inspections, it can be tough to see, it can be tough to be consistent, and then you have different shifts as well. So it can drastically differentiate between shifts on the quality inspections that you're doing. And you really want that consistency through all and that continual training. And then labels. So wrong labels, we do inspections with barcoding, as well as damage to make sure the right labels are on parts. And then just-in-time parts, really looking at, hey, the amount of objects that we want to see, are they in those models? So that's just giving you guys a few use cases, and we'll go through a couple of those today. And then if you have which one, we have a couple different demos that we could show in the future if you reach out with more questions. So the last one, this is a big one that we've been trying to solve for a long time, and that's really with welding. So all my welding engineer buddies in college all brag about how much money they make, because welding is very intricate and it's a lot of pieces to it. And it's something that is an issue that I used to see within my engineering project management life, as well as I hear all the time, is this really with manual inspections visually, you're able to think that something's a good part or a good weld, and then you cut it open and it's not to the quality or expectation that you're looking for. As well as there's a small sample size, so you're not able to inspect each one. It's usually a small sample size that they will take out during the day, every couple of hours, to make sure that the welds are how they're supposed to be. So what our solution was actually a 3-part piece. One was visual, where we actually had 2 infrared cameras looking at the weld itself to see really is the weld happening as it should be. And then acoustic, we're looking at 2 different types of listening devices to also get more data analytics. And then parametric, so information coming off the PLC, the controller, that's really giving us that full picture of what's going on. And then we use AI optimization. So if you have multiple welding cells throughout your facility, you can figure out which model, which data is giving you the most information and bang for your buck to predict bad welds. So it's really not condensing you to one solution. It's getting you all of the information that you need and figuring out what is the best storyteller for we're having issues with our weld. And the benefits were that we were able to do quality insights of 100% of those welds, and then a reduction in labor, material, and scrap costs. And they're estimated to save $18 million in 1 year at one plant. So now I want to go into a demo, and I made this list because I'm going to show a lot of things because this product is so cool, and I want to make sure that I'm respectful of time, and then we go through each one of these. So we'll actually go through the visual inspection, really web browser, and we'll go through collecting, training, and then test and deploying these models. And then we're going to do inspection on the edge. So on an iOS device that I will show locally, where we're going to go through some models. We're going to have one model triggering another, one device triggering another, and then we'll look at the dashboarding, so how we're performing, and then MQTT alerts. So when we do see those defects, we're making sure the right people are getting alerted, that we can then go ahead and make the correct countermeasures. So it does look like it's showing that screen. I will pull this over. Put that there. And go ahead and screen mirror. We can pull this to my second desktop. So what you're seeing is my iOS device, which I have already pulled down 2 models locally. So this is the 2 flavors that I was talking about. You're really building the models up here in the web browser, being able to test and deploy and train them there. And then you're able to execute the inferencing models that you have here left on the left side locally. So I'm actually going to put the phone away for a few minutes, and we're going to go through how we create these models. And I really like this infographic as soon as you log into Visual Insights, because it's telling you exactly the steps that you're going to go through to create these models and deploy them. So create the data set. That's getting the data set to train the models, preparing the data, telling the machine learning model what's important to it, and then training the model testing the model to accurately see if it's showing and detecting what you want to, and then deploying that model to your iOS device. So that's also up here in the tabs. So we have data sets, where my good friend John Ward, I believe he's out there on the line, did all the hard work for me. We're going to be focusing on a Volkswagen wheel today. And what he did was he uploaded all of these photos of good Volkswagen wheels, bad Volkswagen wheels, with good bolts, wrong bolts, missing bolts, and also defects. Then what he went ahead and did was he selected all of them, goes into our labeling, which is very similar to Microsoft PowerPoint. If you can do that, you draw boxes around what's important in these photos. So good bolts, wrong bolts, and different defects that you then want the model to start being able to detect. So he did that for each one of these photos. And then after you create these models, you can do auto labeling in the future, so that it will go ahead and do that labeling for you and it's not as tedious. So once you're done labeling your objects, what you can do is, if you don't have too many photos, which happens often with defects, especially if they don't occur all of the time, you can go ahead and augment the data so you have more photos to help that model train and understand more. So a few of them are blur. That's one we use pretty often in automotive since things are moving on a manufacturing line. Color to do with different lightings, and then sharpen, rotate, crop, noise, vertical flip, and horizontal. So these are other pieces that if you have a small data set, you can make it a larger data set, but you also want to make sure you don't overdo it. You can create more data for these models to train on. And then you can also come over here and look at different objects. So these are all of the things that we want to be detecting for when we go ahead and do our inferencing. But since we are already set with that, I'll go ahead and actually just train a model that's very quick, just to show you how it would all work if you were to use visual inspection. So there's really 3 types of training that we can do, with object detection being the predominant one that we use most. So image classification is one that looks at the pixels, and it's really for if you wanted to differentiate between the Volkswagen tire that's 24 inches or 26 inches, that's the type of model that you would use there with image classification. And then object detection is what we'll be going into, and then action detection is the last one, which is, again, if we want to go with the wheel, you want the lug bolts to go on in a certain order. That would detect for that order was done in the correct order and be able to inspect based upon the actions. But we're going to stay with object detection, and there's a few different models even within that. So if you want to do it locally on an inferencing server or you want to do it on an iOS device, you can choose between those. The fan favorite is YOLO V3, which uses Core ML, which can be run on an iOS device, as well as you can come over into advanced settings and pick iterations, training partition, and test partition. So I'm just going to put this for 200 iterations, and we can watch as this model trains in the background. Now, as we keep moving, these are all the models that I've created over the past few weeks and John has created as well. And what you can do is you can actually create these models, different flavors of each models, and see which one's performing the best. So as you can see up here, I have a few that are rejected. I have one that I really like, 2 that I really like, and I can move those into production. And then as we keep moving, we go to our deployed model. So this is where you do the testing and you're able to do it up in the server. And I wonder if sometimes they come and clear out because it uses more GPU. So we'll just have to deploy one really quickly. And let's deploy that model. And then that's my inspect model. We'll give it a few seconds, and I'll come back to it and show you how you can do testing on the server. So once you've deployed the models, you're ready to start projects. I've got 3 different projects that I'm currently working on. The VW wheel inspection model, I'm doing some on shower drains, and then I'm doing some on multiple paper clips. So this is a way for you to organize all of the models and data sets that you want to have locally downloaded. So if you look in here, I've got 2. I've got my inspection and detection model, which we'll go into, and then, well, here, and then the data sets that are showing the results of those. And I saw that it was deployed in the background, So we'll go to deployed models. I can go in and I can actually test this model, which I took out some pictures to test to see if it's accurately showing the inspection as we want to, and it is correctly. So the 3 black lug bolts are the ones that are correct. So those are good bolts. The B is the wrong bolt. It doesn't have the cover, and then C is missing bolt. So it's performing as we want to. We can do more testing, but for today, that's just a quick example. So now that I've really showed everything that you do in the browser, so no notebooks, really simple, just drag and show a box over what objects you're trying to detect, you're able to create a model in a few hours that, say you have a new line that you're trying to, look for different defects, you can get it up and running quickly. So now I'm going to go to my mobile and show you how this works locally. And we'll should fill to the screen, but that is okay if it does not. So this is my iOS device that I have in front of me, and I have 2 different models that we looked at before. One is a detection model that's just looking for the presence of a wheel. So you can imagine on a manufacturing line, usually you have to hook it up to a PLC system or a triggering system. This allows for the device just to be set up, look for the presence of a wheel. Once it comes into the frame, it's going to look for how many frames that it's present for, and then trigger the second model, which does the inspection. So we can go into that. I will go in the detection model first, and we can go into capture mode. And I will pull up another one of my testing images. Note, if you're ever doing this, it is really good to be organized. So you see all of the folders that I have, because it can get very hectic if you have a lot of images and a lot of things that you're trying to do. So this is in streaming mode because it's just looking for the presence of a wheel. And as you can see, it's looking for the wheel. It goes ahead and checks for it and tells you the confidence interval right there at 99.58%. As well, I do want to show that there is an overlay, so you can put this down here. So if you're going to do a handheld inspection, maybe you pull something off the line, you can use an overlay to then look at the image, line it up, and do the inspection like that, which is pretty cool. So then you know that you're getting consistency when you're doing those inspections. The second one is our inspection model. So this is really looking at the quality, and I can go into capture mode. Again, I can pull this down here just as a reference point. I go up to the wheel. And it's going to bring back the inferencing and tell me that I have 3 good bolts and then 2 missing bolts. So there's 5 expected, so that's failing for that, and then 2 missing bolts here, so this inspection would fail. Now, the other thing I do want to show in the presence of time, I took some notes to make sure I don't miss anything, is the ability to remotely access other cameras. So I also have my iPad here as well, which I'm going to bring up. And I've got a Slack notification, as you can see. And as long as I'm in this connected up to the same server on my phone, on my iPhone, I can click switch to another device. It's going to find my iPad locally. And then what I can do, and this is going to take a few hands, is I can go into the device, I can click auto capture, and you're going to see my tablet go into auto capture without me having to touch it. And then I can click the model. I can do a detection model. So say this tablet's under a car and you don't want to go back out there and you want to be able to get more photos to keep training models, you can do that locally. And then hit take photo on my phone, and it's going to go ahead and do that inspection as well. So I think that's pretty cool. So I am going to move now completely to my tablet and show a few more pieces. So now that we're on the tablet, we have the exact same models. And really what we're looking at is also being able to have one model trigger another. So I'm going to go ahead and do an inspection of one model triggering another on my iPad. So if I come up here and I go into auto capture mode at the camera at the top, I can start auto capture. It's looking for a wheel for a certain amount of frames. Takes a photo, which then triggers the inspection model, which is the second, looking for quality. And it is a little slower since it's an older iPad. And it looks like we might need to go one more time. So you can see as the wheel is resetting, so that's allowing for it not to take the same inspection as something's moving away on the line after you've already inspected it. And we can go ahead and let it reset. And Tony also has this set up well later on, so we'll be able to see this a little bit more. Might be my iPad. Oh, and then I went to waiting. All right, one more time. We'll give it another shot. If not, Tony has it set up, and I set this up this morning. And it'll take that photo and launch the inspection, which it looks like it might go away before actually showing the results. So it does data collect, which I could show in the dashboarding in 2 seconds by going over the dashboarding to see how we are performing. So able to see the results that we just did. And through our dashboard, you want to see how your line or area is performing. You're able to see the failure rate for inspection, the pass rate, how many images it's inspected, and then also how many photos it collected. So you can set it to collect passes, you can set it to collect failures, and it's really up to you at that point. So I can also go into the images, see what it passed and failed for. So I believe this was the one we just did, and it's showing the 3 good bolts and the 2 missing. And you could go through and figure out where you're having issues and retrain models continuously. As well, and we will show one last piece. As these defects are occurring, you're able to send text messages or different communications to operations managers, maintenance managers saying, hey, we're having issues for different inspections and why they're failing. So if you look at this, it's actually doing some error codes. It's looking at wrong bolt, which is getting sent locally, wrong wheel, iPad failure for wheel, wrong bolt, so that you have information as you're going out to then do the maintenance and the corrective measures. So with that, we'll go back to the slides. As long as that's up. We are good. So what we saw there from the visual inspection web browser, we were able to collect, train, test, and deploy models, and then do inspections on the edge. So looked at some different models, detection, and then inspection model, one model triggering another, and then one device triggering another, as well as dashboards, and then the MQTT alerts, which you saw in the text messages at the end. Now, John Ward put this video together the other day as we're connecting this with actually our AR capabilities as well. So 2 solutions, and this will show you a little clip of what he was doing. So as you can see on that same use case, you're talking about merging the AR and the inspection as well. So a person can see, what steps they're supposed to be taking in if they're wanting to manually inspect maybe after a lease, different parts of a car, and go to the rims, the wheel, the mileage, and that type of piece, and go through each one of those steps, and it's consistent every time, and then your data collecting on all of those for being able to report back. So 2 quick case studies. The first one is a major global OEM that we've been working with. And what we did was we were able to, there it is, sorry, I apologize. We were able to put an iPhone out on the line. They didn't want any cords, they didn't want anything, so they put a battery pack on it, also built out a case, and within the first 30 days, they prevented 32 missed builds on that line from that device. And then over time, we scaled it out to 14 different stations where now they are able to inspect 250, will prevent 250 missed builds per day. And one of the CIO for that company said, I want this solution installed in all of our vehicle launch sites immediately. So it's pretty cool to see the product work that well, go in and be able to, stop issues and pain points that our customers are seeing. And then back to the welding piece that we had. So really the 3-prong, the looking at visual inspection, the looking at acoustics, the looking at the parametric, and bringing that all together into optimizing what AI model is giving them the most information on what welds are good and what welds are bad. And at one site, they're looking at reducing cost between overtime, labor, rework, scrap, and really the whole effort that goes into defect issues of reducing it by their cost by 18 million per year for one plant. So you might be asking, how do we go through our process with our clients? So we'll come in and we'll do a 2-hour demo. You'll see a lot of what you saw today where we're showing you the technology, introducing it to you so you can ask questions. And then after that, we will do a proof of value. And that's really a 1-day workshop where you come up with 2 to 4 use cases on defects that you see and you would like to be able to stop at the point of installation. And we'll come in, be able to collect photos, and usually by late lunch, late afternoon, be able to show you that we're able to inspect and detect those defects on your line. And then this one's dependent on the customer, do 4 weeks of a production pilot, and then do a production at scale after that at 2+ months mark. So that's it from my side. I do know that Tony has been putting a demo together with some engineers that he really wants to show. So I saved him some time. And if you want to, go ahead, Tony, and do your live demo.
Okay. Thank you, Morgan. As Morgan said, we wanted to do a demo involving some real cars. Unfortunately, Furman wouldn't let us drive a car in here. So I took 2 of my senior automotive engineers, Joel and James. They are aged 10 and 8, to build me a couple of models from their Lego sets. And we've got them right here. This is the James, and this is the Joel model of the car. So we've got our little production line set up. Now, just a little quick background on me. I have a biology degree in undergraduate and an MBA, and I spent most of my adult life in the Army. So I don't have a whole lot of coding experience or experience involved with data science or machine learning. And I was able to, in 4 hours, put together this model. And I'm going to pull up the screen here. Morgan, can you? Okay. There you are. Yep. We'll just wait for the code. Okay. It should be coming up right. No, it's not showing up there. There we go. Okay. And there's my daughter right there. She's actually helping me program this model right now. in this picture. So what I've got here is I built a model to detect the gray car, the James, and the yellow car, the Joel. And from there, trigger an inspection on the Joel looking for the right kind of wheels. So imagine these are actual, this is an actual assembly line. As you can see, it's picking up the gray car. I'm going to bring it over here. It should pick, there's the yellow car, picking it up, does an inspection. So it actually failed that inspection. So let me try this one more time. There, it says 2 good wheels. So what I did to test this, even make it one level further, I'm going to invert one of the wheels and see if it picks it up. So again, get down here, inspect, picks up the car, triggers it. Got a good wheel, we got a bad wheel. Let's do it one more time. Good wheel and bad wheels. So this, I mean, imagine that this is your assembly line in a factory, and this took me from start to finish, total of 4 hours. That includes labeling, picture taking, uploading the pictures, augmenting the files, and then running the model. 10,000 iterations on YOLO using Lego cars. So it's really easy to use for somebody like me who's kind of simple when it comes to programming. So then the next step is to get my children to actually start building their own models with their Lego cars. That's going to be the project for the fall. So thank you for letting me demonstrate that, Morgan.
No problem. Appreciate it. And then we are to questions. So we can open up for questions if we have questions out there. We're actually early on time.
If you have any questions, you can ask on the chat, or you can unmute yourselves directly on Teams, or if any questions from the room. We have any questions, Rafa?
I'm going to reach out directly to see if something that we can do with the construction.
Okay.
Just to mention that. Great.
Thank you.
Yeah, we have Rafael from the Power Tools area, and he said he will connect with IBM separately. Any questions from the pressure side?
Thank you.
Really good.
Thank you.
Good. On the line, if you have any questions, just you can unmute yourself. Just want to make sure we don't have any echoes.
Hello. I have a question.
Yeah, go ahead.
Okay, so my name's Kelly Linder, and I'm from the aerospace industry, and I'm familiar with the object detection and the visual identification tools. We've used them at our company, and so my question is related to, so we were looking at the lug nuts, and it identified if it was an incorrect one. So one of the issues that we have with large, say, bulkheads or something like that, that has attachments that you could consider to be like a lug nut. It has a certain space that it's supposed to be in. Sometimes, because we have lots of fastener locations on an airplane, those brackets could be installed, say, an 1/8 of an inch or a 1/4 of an inch off. In other words, they could be installed at a fastener location that's incorrect, but not by very much. Is it, I mean, how would it identify that? Because it wouldn't necessarily be a missing bracket. It would be there. It would be just incorrectly located to that spot. And I'm asking because I'm looking at the inspections of the engine. And so that looks more closely intricate to an airplane.
Yes. And now there's feedback. Great question. So it's worth having a follow-up conversation about exactly what you're thinking is the connectors within the engine to make sure that those are connected correctly. So there's a couple different ways you can look at doing the object detection and detecting if it's disconnected or it's connected incorrectly. We have some experts that are really smarter than me at this because it's just moved over, and they'll know exactly how they've, boxed those object detections within our models to be able to detect that. So I think it'd be better. I can give you a answer, but I'd rather get you the right answer. And I think it's worth a follow-up conversation because I know John Ward might be on the line as well, and he was a part of that project, and he may be able to answer that, how they did that there.
That's exactly what I was going to say. Is I don't want to put John on the spot, but if he wants to unmute and talk about it, he's done something similar, I think.
Yeah, this is John. Can you hear me?
There he is.
Yeah, on the engine, I mean, that's really one of the more popular use cases in automotives is electronics connectors. So we're looking at seated, soft seated, and unseated, and you're looking at millimeters there doing detection. But on the aircraft example, we'd like to take a look at that a little more in detail. You can detect variation in placement, but not really fine, in which case maybe we need to leverage some of our other technology to actually do that distancing. It just depends on how accurate you have to be. Is it an inch or is it a few millimeters? So that's something we'd like to take a look at. We got different tools to help with dimensional analysis too as well. But if you could send us an email or to Morgan or Tony, we'd like to follow up with you on that one and get you a more precise answer if we could, please.
Okay, this is Kelly again, and I don't think it's a situation where you have to necessarily overlay the engineering. So not, it's an airplane, so we have close tolerance holes sometimes that are, very close. But a lot of times with the installation of brackets or standoffs or any of the things that you might put intercostals and things, it's a matter of they can be placed in the wrong fastener location that is not per engineering, but it's not off by great distances, but it is off it's not close enough that you can look at it visually and go, yeah, I'm off 2 fastener locations on this bracket. You might not be able to see that without exactly looking at the engineering, but it would seem like it'd be detectable at least to some degree. Not down to the level of engineering, but at least that it's off by a quarter of an inch or half an inch or something like that.
Well, that's the great thing about the tool. You can go give it a try for an hour or two and see if it works. The other thing you can do too is, for instance, what that part should look like. You can overlay the reference image like he was showing you a minute ago too. And then, of course, one of the things, matter of fact, I was just talking to our AR team about inspecting the bulkhead, about correctly positioning the handheld to actually look at those parts. So just about an hour ago. So it's kind of funny you bring this question up. But no, we'd like to follow up with you and take a look at, because we are looking at adding maybe some LiDAR capability too as well, so we can get very, very accurate on our measurements. Because I'm more in the auto world, and one of the big things in automotives, a lot of use cases, but the thing I keep being asked about is fit and finish, the gap between the doors and stuff. So we're looking at adding some more technology in there. So like I said, if you could send us a note describing what you want to do, we'd be happy to get back with you and try to get you a better answer.
Okay, so I've sent some information to Stephen Ball. So he has pictures and things of what we're talking about. So I'm not sure.
I know Stephen Ball. I will track him down, and we'll go to work on it. Okay.
Okay. Thanks.
No, thank you.
Thank you, guys. So there's another question on the line here, so let me read it for everyone. So the question is from George, and it says, do you have any examples of applying Visual Inspector in the power generation and electric industries?
So my expertise is not within there, it's in the industrial market, but I've seen quite a few use cases where we look at power lines and we use drones, especially in remote areas where the drone will go up, it will be able to, like we had talked about before, detect, a certain part of a power line, and then do the inspection, store it locally, and then once it gets back to connectivity, especially in remote areas, be able to do that inferencing. So you're able to do those inspections like that is the one use case I know. And if Tony, you know another.
I don't know of any use cases off the top of my head again, but if there is, are you talking power generation like you're working at a plant, in a coal plant or a nuclear plant, or are you talking about power transmission using lines and those sorts of things?
You're saying fossil and nuclear.
Fossil and nuclear, okay. So yeah, coal-fired, oil-fired, and nuclear-powered plants. I know we do a lot of work in those areas. Again, that's not my expertise, but I'm happy to go look it up and see if we've got any use cases. I'm sure that it would translate in one way or another, and we can get you in touch with somebody who can answer those questions a little more deeply if you'd like.
Oh, okay, thank you. There's another question from Joy, and the question is, we are exploring using object detection to be used in merchant ships for 2 use cases. So case 1, survey and inspection, and case 2 for machinery maintenance, such as engine, boiler, flow meter, calibration, and performance. So I guess looking for use cases there. If that
would you want me to spell it out for benefit, or do you prefer that I keep writing on the text box?
And if you're unmuted, you can go ahead and just ask more about the question.
Sure. So I am in touch with your colleague in India named Sandeep from your IBM office, and he actually invited me to be part of this session. So we are very seriously exploring deploying this for merchant ships around the world. And this COVID area isn't allowing people to go onto the ships for regular maintenance or survey or inspection. So this has actually started disrupting the existing processes, and we want to leverage this experience by not only taking video and images, which ends up landing up in a cloud repository, people end up looking at it. We wanted to automate it and see if I see something weird, if I see rusting happening, if I see oil leakages, if I see any kind of vibration, which ideally should not have happened beyond certain millimeters, and the ships get stranded mid-ocean, and that's like not even a chopper can reach deep inside the ocean. So it's like a major expense item, whereas we leverage a lot of visual imagery and videos to be sent over VSAT. Now, what I want to understand is any use cases, anything in industrial scenario which could closely replicate this. It could be automotive, it could be airlines, it could be anything. But as long as we get to know that we can use images to actually come up with the intelligence so that people remotely need not go frame by frame, and that defeats the purpose. So that's like we are trying to bring it on, and really appreciate if there is anything closest to this so we can actually take a cue from this. Yeah. Thank you.
Yeah, there was a lot there. I think it's very similar to what we kind of talked about before with the person asking the question before. It's worth taking a deep dive. Sandeep is a good person to be in contact with. You're in good hands. I think really going through, because I heard a lot there, and I think I definitely want to explore exactly what more of you're looking for. But I think there's definitely some things that come to mind that we can definitely talk about. I just want to definitely still understand more.
So I actually have a couple of follow-up questions. Are we talking that they're doing these inspections when they're out on the open water, or are we talking in dock, either in the harbor or up in dry dock when we're doing the inspections?
Yes, when people actually visit, it happens in the ports when people actually fly in from different countries, take 16 hours flights, and they reach up over there. Whereas we want to do it while the vessel is already in motion. It saves time, saves money, is faster. We can make it on demand. So people can just demand that tomorrow, XYZ time, we want to conduct it.
I think you said VSAT. Is
Yes.
that how you transmit from ship to shore when they're out in the open water?
Ship to shore, you're right.
Oh, okay. I've transmitted over VSAT, and it can be cumbersome. So yes, this is something that it'd be a really interesting use case and boy, I wish I could be a part of that, to go out on a boat in the middle of the ocean and see if we could get it to work remotely out there. But I think that is definitely something that will be an interesting use case to play around with.
Hey, Tony, this is John. Just a concept here. I mean, over in my world of robotics and conveyors, which are not ships, but leveraging the augmented reality to step you through I was talking about an inspection procedure and recording it. That may be an option.
You know, remote locations. Obviously, the boats are out in remote locations. You can take that information, store it locally until you get connectivity, and send it back for the inferencing and like that. So I think it's just, I don't know if that's exactly what you're looking for. I think it's worth talking about more and truly understanding, because that's not where my expertise is. So, but we can definitely help out.
All right, excellent. We have 2 more questions and 8 minutes to go here. The next one is actually a really good question regarding interfaces. So the question from Susan from Bosch is, what kind of interfaces do you have to connect the IBM Vision Inspector to further analysis tools or to trigger automatic reactions?
So you're talking, is she asking about so that you could have other people get that information?
Maybe other devices, you know, it could trigger automatically, you know.
Other analytics tools?
So we have it set up, at least now, so it's on, you know, an MQTT server for our use case that we're using, but there's a few out of the box, and we'd have to pick into more what you're looking for, where it immediately sends that information back to wherever you want it to go. So that's interesting. I haven't gotten that question yet, but I know we have different ways of communication, so it'd be worth, again, having everybody follow up.
Is that a question that, I don't know if Dave or
John might know as well.
Hey, this is John. Can you hear me? This is John. Hello? Can you hear me, Morgan?
I can hear you.
Yeah, we can hear you.
Yeah. That one we do a lot of, which especially like in auto manufacturing. When we've got like an iOS device out on the line, yes, we do need to communicate upstream. So we've got the capability to integrate to like the andon systems, quality systems. We can talk directly back to PLCs. So we do have an integration outbound to feed the data to other systems. And we also have our own tools too for doing analysis that we also provide. Our dashboards, our drill throughs. For instance, we have a dashboard that we can look across all the devices across the enterprise, and we can look at each station, drill through all the way to see how it's performing. So we've got technology within, and then we can also feed the data to your existing systems that you may have need for too as well. So a lot of capability there.
Okay. Thank you. Question, I guess. Object detection using, well, the question is the object detection performed using a pixel count? And if so, how do you handle lighting or contrast variation without having to light the object?
So I've been digging down this one and haven't got the total answer yet. I believe it's pixel, but I can answer the second question with the lighting. One of the augmentations that you can do is color, and that's going to be able to darken the photos, lighten the photos. So if you're in an environment, maybe outside, that changes light, dark, you can put those augmentations on, and that's going to help train the model to understand what you're looking for in different types of light or environments.
I was going to say that the outside use cases are where it's done, but a lot of the ones that are inside, the lighting doesn't. It really does.
And I will say I've experienced that where I had it detecting very well in one light, changed lights, had an issue, understood that, then went back, did the augmentation, retrained the model, and there's no more issue. So it's one of those continuous learning things that allow you to keep developing the models. All
right, excellent. Thank you. So I think maybe we have one time for a last question if anyone has in the audience. I see some people dropping off probably to other meetings. So if there are no more questions, I would like to thank Morgan and Tony very much for their awesome presentation. We're gonna do a clap in the room.
I do have one thing that I have to do. That I have one more child that I did not bring up on my call. And since this is being recorded, I need to say thank you to Jake for helping me film and take the pictures for the models. I didn't bring them up when I was talking earlier. So thank you to Jake as well.
Excellent. You have to be even. It's very important.
Right.
Very good.
Love
Excellent.
all the kids the same.
So, thanks for keeping the connector spirit going, guys. This is exactly the type of content that we want to bring to our audience, which is IoT, new technologies, new ideas, new tools. And, thanks for taking the trip. And we'll be happy to see you again very, very soon out here.
Thank you, guys.
All right.
Thanks, guys.
Thank you. Have a good day, everyone. Thanks for joining. Bye.